Hello, in this short video I'm going to talk to you about electron micrographs. They are pictures that are taken with electron microscopes. So there are two types of electron microscopes. You have the scanning electron microscopes. Now they bounce electrons over the surface of cells and organelles, and they give a 3D picture of the outside of a cell or the outside of an organelle. The transmission electron microscope, however, it allows you to see the inside detail. So they allow you to see what's inside the actual cells. So the cells are taken and they're sliced up, and then those slices are stained with heavy metals so that electrons can get more easily through some areas than other areas. And as a result, you end up with a black and white picture which shows you what is actually inside cells. Now, in electron micrographs, you need to be very aware that things can appear in different ways. For example, if a mitochondria has been cut longitudinally, so it will be cut along this way, then the mitochondria would appear like this. But maybe in an electron micrograph, you're told it's a mitochondria, but it looks like this. And that's simply because the mitochondria has been cut along a different plane of section. It's been cut transversely. So look out for that in questions. Why would the mitochondria appear differently in one section than in another? And it is because it has been sliced in a different way. So now I'm going to talk for a minute just about magnification. Magnification is how many times an image is greater than the actual size of the specimen. So that's what magnification is. And in words, magnification is the size in the image, so that would be what you measure on the electron micrograph, divided by the size that the specimen is in real life. Now, I like to say that M is equal to A divided by R. So M is equal to the size in the image, how it appears. That's what A stands for. So when you're looking at that electron micrograph and you get your ruler out and you measure something, that is how it appears on paper, and then divide it by the size that it is in real life. So magnification is A divided by R. Make sure you get out your photo booklet and you practice working out magnification and the size it is in the image and the working out what it would be in real life. You probably will get one of those calculations. When you're working on those calculations, please make sure that everything has the same units. If you measure something in millimeters, please change it into micrometers. And then look at the question, are they asking for the answer in millimeters or micrometers? So just to remind you, if you have something in millimeters and you want to know how many micrometers is, you just multiply it by 1,000. And if you have something in micrometers and you want to know, well, how many millimeters is that, you take your number and you divide it by 1,000. So make sure that you know how to do it. The last thing I then want to mention is how would you measure cells more reliably? So if you want to increase the reliability of your results, especially with the eyepiece graticule and the stage micrometer, you would take several measurements and then you would calculate the mean width. Now remember, reliability is always about repeating and calculating averages. Then what if you were asked, how would you measure the cells more accurately? The most accurate way to measure cells is to use high power. And the other thing that you have to do whenever you're measuring cells and comparing cells is that you measure them in a consistent way. So for example, if you were measuring the width of a plant cell, you would measure from middle lamella to middle lamella, but every plant cell should be measured in exactly the same way, and that makes your measurements consistent. Okay, can you make sure you get out your electron micrographs, please, and that you can work out magnification and actual size and all of those other things? There is no doubt that you will get an electron micrograph question.